Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to our YouTube channel Paper World, where we are solving past paper questions of IGCSE Physics 0625. So today we are starting a new topic, electricity and magnetism, and let's begin with the topic 4.1. But before we start, kindly like and subscribe the channel. And if you find anything helpful over here, kindly remember me in your prayers. Thank you. So let's begin. Question number 1. The diagrams show two arrangements of pair of identical bar magnet. 3 points P, Q, R are shown. At which point is the magnetic field due to the magnet's weakest, and at which point it's the strongest? Okay. So these two magnets are kept with like poles towards each other. So obviously the magnetic force is going to be the weakest over here. Okay, and over here these are two unlike poles. So I'd say okay, and we know that the magnetic field is from north to the south, and over here it's going to be stronger than it is in the middle. Okay, towards the side it's stronger. So R पे there is going to be the magnetic field that's the strongest, and P is the point where it is going to be the weakest. So if we are looking, so the V is our correct option, which states that weakest magnetic field is P and strongest is at Q. Okay, question number 2. The hard magnetic material that can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary magnet. Which row shows whether iron and steel are hard or soft magnetic material? Okay, you should now know that steel is a hard magnetic material, and iron is a soft magnetic material. That is why it's used, iron is used for making the core of an electromagnet. Okay, so you should know this because most of the questions related to magnetism, simple magnetism, are linked with iron and steel. So iron is hard, steel is hard, and iron is soft. So C is going to be the correct option. Okay, you should just clear it out at this moment that iron is the softer one and steel is the harder one. Okay, and permanent magnet is made from steel, and electromagnets are made from iron. Okay, question number 3. Which metal could be used for a permanent magnet and which metal could be used for the core of an electromagnet? So a permanent magnet is always going to be made with steel, and the core of an electromagnet is going to be made with iron. Okay. Question number 4, which metals can be attracted by a magnet? Okay, zinc is not a magnetic material. Lead won't be attracted by the iron, and copper is also not a magnetic material. So iron is the magnetic material out of all these. Okay. Okay. Not every metal is magnetic. Kindly remember that. Question number 5. The magnetic field of a bar magnet can be represented by magnetic field lines. Which diagram shows two magnetic field lines correctly? Okay. The magnetic field lines start from north and go towards south. So this seems to be correct. It's not this way, obviously. So this is not correct. They start from south and go towards वो अच्छा ये भी north की तरफ जा रहा है. ये it's starting from north, but ये south में से भी निकल रहा है and it's coming out of the north as well. So this is also not correct. So this is option A is the correct option. Okay. Question number 6. An unmagnetized piece of soft iron is placed close to a strong permanent magnet as shown. What is the induced polarity of X of the soft iron, and in which direction does the magnetic force act on the soft iron? Okay, so if this is north and this is soft iron and it is going to be attracted towards it. So we know that the unlike poles, they attract and the like poles of the magnet repels each other. Okay, so if it's obviously when you place a soft iron thing close to a magnet, it is going to be attracted towards the magnet. So obviously over here its south pole is going to be induced. Okay, and the direction of the force would be on the left. Okay, because it's going to go over here, so it's going to be to the left. So C is the correct option. ठीक हो गया? Question number 7. The diagram shows the magnetic fields around a solenoid carrying an electric current. Okay, solenoid is this coil-shaped thing carrying current. Okay, what happens to the strength of the magnetic field and the distance between the field lines when the current is increased? Okay, current and magnetic field lines are directly proportional. More the current, closer will be the magnetic field lines. Okay, so the strength of the magnetic field is going to increase and the distance between the magnetic field lines is going to decrease. Okay, so C is going to be our correct option. Question number 8. Which row gives the metal used to make the core of an electromagnet and one property of the electromagnet? Okay, the core of the electromagnet is always made from iron. ठीक हो गया? And its property that it is used for an electromagnet is that it's a temporary magnet. Okay, so B is going to be our correct option. Question number 9. The diagram shows a bar magnet at rest on a smooth horizontal surface. The length of soft iron wire is held parallel to the magnet. The wire is released. What happens? Obviously, this is a soft iron wire. This is a magnet. So, what is going to happen is that the wire obviously is going to get attracted to the magnet. So now we'll look at the option. The wire moves away from the magnet. This is not correct. This is a magnetic material and magnet is going to attract it. The wire moves towards the magnet. Yes, this is correct. The wire's center stays at its present position and the wire rotates 90° in a clockwise direction. Not necessarily. The wire and rotates 90°. This won't happen, obviously. The simplest possible explanation is that it's going to be attracted towards the magnet, so it's going to move towards the magnet. Question number 10. Two magnets X and Y are placed end to end on a bench. The diagram shows the magnetic field pattern between the poles of the magnet. Which row shows the direction of the force exerted on X and Y by the magnetic fields? Okay. So force on X is in this direction and force of Y is in this direction. Why? Because this is basically our north and this is our south. So they are going to be attracted towards each other. ठीक है ना? As you can see that the field lines are always from north to the south pole, so they are moving like this. So this would be the north, this would be the south, looking at the magnetic field direction of the magnetic field lines, and they are going to be attracted towards one another. So north is going to move towards this side and south is going to move towards this side until and unless they are both close together and attracted to connected with each other. Okay, so B is our correct option and no other option is suitable for these conditions. Okay. Question number 11. The diagram shows the magnetic field around three objects P, Q, R placed close to each other. Okay. Which row shows the nature of each of the object? Okay. This is P, this is R, and this is Q. Okay. P is a permanent magnet, obviously, and R is a permanent magnet as well, and this is something that's lying in between them. So this obviously is going to be some magnetic material thing, ठीक है ना? लेकिन this isn't being attracted to this or this. So I think this is going to be something which is not magnetic. Well, let's look at the options. So P is a permanent magnet, Q is a copper rod, R is a permanent magnet. Yes, this is correct. But what we have to do is we have to see the orientation. Now the magnetic field line, the direction of the magnetic field lines is like this. So we know this is going to be north and this is going to be south because they are from north to south. And over here, this is going to be north and this is going to be south. So they are going like this. So over here, north, south. So this arrangement is not correct. So option A is not the correct option. This one is the arrangement is correct. So, and iron rod is not there because it's not being attracted to either of the magnets. So it's something which is a magnetic material. Okay? The copper rod it is going to be. So 11 ka answer is B. Question number 12. A student shows how many counts how many iron pins an electromagnet picks up when its power supply is switched on. Then she counts how many pins are picked up when the power supply is switched off. She repeats the experiment using cores of different materials. The results are shown. Which core is made up of soft iron? Okay. Now pins picked up with the power supply on. So 0 and 0, okay. Pins picked up when the power supply is on 2 and pins picked up when the power supply is off 7, okay. Which core is made up of soft iron? Okay, let's look at the options and then I'll explain. Picked up when the power supply is in on 8 and 5. So D is going to be our correct option. Okay. And why is it so? Because they've asked us that which core is made up of soft iron. So soft iron the core would be of iron, okay, which is a temporary magnet, okay. So it's not a permanent magnet. So when the power supply is on, it's going to convert into an electromagnet and pick up pins. But once the power supply is off, it is not going to pick up any pins. All these are picking up pins even after the supply is off. So they can't be made up of soft iron core. Okay? D is the only option that's made up of soft iron core. Okay, moving on to question number 13. A student attempts to make a permanent magnet by hammering metal bars of the same size in the same magnetic field. In which case is the strongest permanent magnet produced? Okay, the strongest permanent magnet is produced when these are magnetic field lines, this is steel bar. एक तो ये कि iron bar की जगह you have to use steel bar because this is a this is a temporary magnetic material and its steel bar is a permanent magnetic material. So they have to make a strongest permanent magnet. So steel bar is going to be used and iron bars are not going to be used. Okay. And then if you want to make a strong permanent magnet, you have to keep the steel bar parallel to the magnetic field lines, ठीक है, as opposed to keeping it perpendicular to the field lines, ठीक है. So C is our correct option. This question comes many times in the exams, so just remember this, okay. Question number 14. 3 piles of small nails P, Q, and R are placed on a bench below 3 electromagnets. One set of nails is made up of copper, one of soft iron, and one of steel. Diagram 1 shows the situation when the electromagnets are switched on. Diagram 2 shows the situation when the electromagnets are switched off. So here the electromagnet is switched on and here it's switched off. So what do we have to see? Which row correctly identifies the material from which the nails are made up of? Okay. Now these nails would be made up of copper. Okay, because copper is not a magnetic material. So even when the electromagnet and the switch is on, so these nails are not picked up. Okay, so Q and R nails would be made up of either iron or steel. Okay, so now we look at these options. So over here, when the switches are open, these nails would be made up of iron because once the switch was not closed, so these nails fell down. Okay, and these must be made up of steel because even when the switch is not closed, so these pins are still attached. Okay, so P would be copper, Q would be soft iron, and R would be steel. So I think A is our correct option. Moving forward, which method does not demagnetize a bar magnet? Does not. Okay. Heat the bar magnet and place it in the east-west direction to cool down. Yes, this is going to demagnetize it. क्योंकि अभी आपने देखा था ना कि हमको अगर मैग्नेटाइज करना था तो हम इसको पैरेलल रख रहे थे to the magnetic field lines, or as opposed to ये जब वो east west direction में पड़ा हुआ था, तो that is going to demagnetize the magnet, not magnetize it. So this is correct. Place the bar magnet in the east west direction and hammer it. Yes, this is also a correct option to demagnetize bar magnet. Place the bar magnet in a coil connected to an AC supply and slowly withdraw it. Yes, AC supply it is going to get demagnetized. And D, place the bar magnet in the coil connected to a DC supply. Yes, this is the only option that is not going to demagnetize a bar magnet. All three other is going to demagnetize the bar magnet. Okay. So question number 16. A magnet is suspended by a cotton thread. A magnet is displaced, then allowed to swing freely until it comes to rest. Why does the magnet always comes to rest pointing in the same direction? Obviously it is going to come to rest pointing in the same direction depending on the north and south pole of the earth. Okay, so we look at the options. A, because of the interaction between the electric field of the magnet and the electric field of the earth. There is no electric field of the magnet and there is no electric field of our earth. Because of the interaction between the electric field of the magnet and the magnetic field of the earth. There is a magnetic field of the earth, but there is no electric field of the magnet. Okay? Because of the interaction between the magnetic field of the magnet and the gravitational field of the earth. No, it's not due to the gravitational field. It's due to the magnetic field of the earth. Because of the interaction between the magnetic field of the magnet and the magnetic field of earth. Yes, this is our correct option. Okay? Question number 17. Diagram 1 shows a small compass needle with its poles marked. It is not near any magnetic material. Diagram 2 shows a bar magnet with its poles marked. The compass needle is placed at point P. Okay. In which direction will the north pole of the compass needle point? Actually, it is going to point towards the Earth's magnetic field. Okay. So if this north pole of this magnet is towards this side, so the compass needle has to point towards the right side. Okay, if the magnet has the pole or north pole on this side, the north pole of the earth is going to be on this side, so this is going to point towards this side. Okay, to the right. Yes, to the right is correct. Okay, a bar magnet picks up two steel bolts. Which diagram shows the magnetic poles induced on the bolts? Okay. If this is south pole and this has to be attracted, the bolt has to be attracted to the magnet, there should be north pole on this side. South and south poles are like poles, so they will repel. So A is not the correct option. Over here, it's the same case, so this is not an option. So over here, it's south and it's north. And the other point is south, but this again are two like poles and they will repel each other. So this is not the correct options. This is north, south, south, north, and south. Yes, D is the correct option. Always remember the fact that like poles attract each other and unlike poles repel each other. ठीक है ना? These are easy, straightforward questions. 90% of them are. Some are a bit tricky. लेकिन ये कि if you know the basics, you are going to be, inshallah, doing them with great ease. Okay, question number 19. A piece of steel is slightly magnetized. It is hit several times with a hammer. What effect will this have on the steel? Acha, if the piece is placed parallel to the magnetic field lines, so it is going to get magnetized and it is going to become a very strong magnet. And if it's there in east-west direction, or perpendicular to the magnetic field lines, so this is going to be demagnetized. ठीक है? So we'll look at the option. The steel is parallel to the strong magnetic field. If the steel is parallel to the strong magnetic field, it becomes magnetized more strongly. ठीक है? And the steel is at right angle to the magnetic field. This is the case. So it becomes magnetized more strongly. No, this is going to this position of the steel is going to demagnetize it. It becomes magnetized more strongly. This is correct. It loses magnetism. Yes, this is going to be demagnetized and it is going to lose magnetism. ठीक है? So this position magnetizes and this position demagnetizes. ठीक है? Always remember this. Question number 20. A student sets up 4 experiments using bar magnets and other metal objects. The north and south pole of bar magnets are labeled N and S. Which pairs attract each other? Okay, now we know that like poles attract and unlike poles, like poles don't attract, like poles repel. मैं भी पता नहीं किस उसमें बोल गई हूँ. Unlike poles attract. Okay, so let's look at the options. This is going to show attraction. Copper is not a magnetic material, so there isn't going to be any attraction. Yes, over here it's going to be attraction as well, and these are two like poles, so they will repel each other. Okay, so 1 and 2. So A is going to be our correct option. Moving forward, question number 21. A piece of steel is slightly magnetized. It is hit several times with a hammer. What effect will this have on steel? I've told you many times. Placed parallel in the magnetic field, it is going to become a strong magnet. And if placed perpendicular to the magnetic field, though, it is going to be demagnetized. So it becomes a strong magnet. It becomes no. B was the correct option. We've done this question before as well. Question number 22. Two soft iron pins are suspended from a south pole of a bar magnet. Which diagram shows how the pins are deflected? Okay. This shows that if these pins are attracted to the south pole, so यहाँ पे it's going to be north pole. ठीक है? Here is north and here is north as well. और यहाँ पे there is going to be south pole, and these two pins are attracting each other. So like pole repel each other. So A is not the case. Over here there is no repulsion, no. And if you see over here as well, both are north, so they are repelling each other. ठीक है ना? तो if here there is no repulsion, no attraction, so B is also not the answer. In C, if you see that north and north pole are here, both are repelling each other. And obviously here it would be south pole and both are repelling each other again as well. So C is our correct option. Over here there is an attraction as well, so D is not the correct option. Question number 23. A piece of steel is slightly magnetized. It is hit several times by the hammer. B is a correct option over here. I've explained the phenomena 2 times before as well. Question number 24. A soft bar is a long way from any magnetic field. How can the material of the bar be described? It is magnetic and strongly magnetized. No, it's magnetic but is not strongly magnetized at the moment because it is not near any magnetic field. It is magnetic and unmagnetized. This is the correct option. And these 2K, it's not it is non-magnetic material, it's not correct. Okay, question number 25. Why is soft iron used for the core of the electromagnet? Because it is not a permanent magnet. Soft iron easily becomes a permanent magnet. No. Soft iron is a good electrical conductor. Yeah, this is correct वैसे तो कि it's a good conductor, but the asal reason there should be कि soft iron loses its magnetism when the current in the coil is switched off, as it's not a permanent magnet. ठीक है, so it is easier to make that one an electromagnet. Question number 26. A metal bar is placed inside a current carrying coil as shown in diagram 1. There is a small current in the coil. The bar holds a few nails as shown in the diagram. When there is no current in the coil, the nails drop off. Which row is correct? The nails drop off because they must be made with iron and they are not made with steel. And because iron is not a permanent magnetic material, so they are going to fall down once the current is not there. Okay? So metals from which the bar is made, it would be made, obviously this is an electromagnet, so it would be made up of iron, soft iron. ठीक है, ये दोनों options correct है. Effect of a larger current in the coil. If the current is larger, so the bar holds more nails. ठीक है, because current is directly proportional to the magnetic field strength. More the current, more the magnetic field strength. ठीक है, तो 26 का answer would be B. Okay, moving forward, question number 27. A metal sphere is charged by induction. There are 4 stages W, X, Y, and Z in this process. So we have to tell about the process. अच्छा, सबसे पहले तो we should know what the process is. This is a metal sphere that is on a stand. So if you've got to charge it, you've got to bring a charged plastic rod, चाहे वो positive हो, चाहे negative हो, जो भी आप whatever charge you want to induce, you have to select your rod with that charge. ठीक है, अब for example यहाँ positive charge है, तो when it is brought near this sphere, so all the negative charge is going to concentrate on this side. ठीक है, because opposite charges attract as well. और यहाँ पे positive charge is going to, उसके बाद this thing is going to be earthed. ठीक है, so as there is more of a positive charge over here, so electrons are going to move from the earth to the sphere, okay, and their concentration is going to increase. Okay, so this is our first thing that we have to do. W is first, the sphere is earthed is not second, the charge rod is taken away from the sphere. अच्छा ये आया ही नहीं. The sphere is earthed, फिर is going to be the second option. And the charge rod is taken away from the sphere. Yes, this is the third thing that we have to do, and the earth connection is then removed. This is the fourth one. Wait. No, this is the third one. This is the fourth one. So W, X, Z, and Y. So B is our correct option. ठीक हो गया? Question number 28. The end of 3 metal rods are tested by holding end Q of rod 1 close to the others in turn. Okay, the results show Q है एक rod और ये these are the points where it's going to be touched. Acha, end Q attracts end R. So Q has attracted end R. End Q attracts end S. ठीक है? So अगर ये दोनों ends ही attract हुए हैं तो one of these is a magnet and one of these is a simple magnetic material bar. ठीक है? End Q repels T. Okay, and end Q repels U as well. So इसका मतलब है कि अच्छा नहीं sorry, it attracts end T and repels end U. अच्छा ये इसका मतलब ये हुआ कि this is a rod made up of magnetic material and this rod is also a magnet. and this rod is a magnet as well. Because iske both ends were attracted to it, so this is a simple magnetic material, rod made up of iron, maybe, or steel. Okay? Or other magnetic materials that are attracted by the magnet. But when the rod Q was brought near T and U, so one of it was attracted and one of it was repelled. So यहाँ पे कोई ना कोई poles होंगे. For example, अगर if ये north pole है, तो और ये नॉर्थ है और ये साउथ है, तो इसने एक को रिपेल किया होगा और एक को ये फिर साउथ होगा और ये नॉर्थ होगा और एक को अट्रैक्ट किया होगा. So this is a magnet, this is a magnet, and rod Q is not. So which of the metal rods is a magnet? Rod 1 and 3 are magnets. So C is our correct option. Question number 29. Iron is used for the core of a transformer and steel is used to make a bar magnet. Which statement explains these uses of iron and steel? Iron is used in the core of a transformer because there the permanent magnet is not required. There an electromagnet is required. So the core has to be made up of iron, and steel obviously is makes up a permanent magnetic material. So it is going to be made for bar magnet. Okay. So iron is magnetic material and steel is a non-magnetic material. This is not correct. Iron is a permanent magnetic material and steel is a temporary magnetic material. No, it's vice versa. Iron is temporary magnetic material and steel is a permanent magnetic material. Yes, C is the correct option. Iron is not magnetic, non-magnetic तो हो ही नहीं सकता, तो D is not correct. Question number 30. Which diagram shows the pattern and the direction of the magnetic field lines around a bar magnet? Okay. So north से south, north से south. तो A seems to be the correct option. ये चीज गलत है यहाँ. This has to be in this direction and this has to be in this direction. So this is not correct. Over here, north, and over here, south. So okay. And D में फिर ये चीज गलत है. So A is our correct option. B में क्या गलती है? अच्छा, B में the magnetic field lines are not drawn correctly. Magnetic field lines have to be drawn like this. ठीक है? They are not like this. From the ends they are, sorry मेरी भी गलत हो गई, लेकिन it's like this. ठीक है? तो इसका the distance between the magnetic field lines is not correct. The shape is also not correct. It's something like this. ठीक है? तो ये बहुत ज़्यादा elongated हो गई है. So this is not the correct option. A is the correct option. Okay. Question number 31. A permanent magnet is placed close to a bar of soft iron. What are the polarities of end P and on end Q? On end P, because this is going to get attracted towards this, so over here it's going to be south pole and over here it's going to be north pole. So any answer that says that P has S on it and Q has N on it, so C is the correct option. Okay. Moving forward, question number 32. Wire P carries a current directed perpendicular into the page. A compass is placed at point Q, which is close to wire P. The magnetic field at Q due to the current is very much larger than the magnetic field of the Earth. In which direction does the north pole of the compass point? Okay. Acha. The wire carries a current directed perpendicularly into the page. Okay. The current is into the page. ठीक है. The compass is located at point Q, which is close to wire P. Compass is over here. Wire P idhar hai. The magnetic field at Q due to current is very much larger than the magnetic field of the Earth. In which direction does the north pole of the magnet point? Acha, we can use Fleming's left hand rule for this. So if the current is into the page, so the magnetic field lines are going to be downwards. So north pole is going to point towards A. Okay, let me see if I can use that figure. Okay, so this is it now. This is for the current, this is for the field, and this is for the force. So if this finger of mine is pointing inwards, so this is going to go downwards, okay, and force is going to be on this side, okay. So A is the best option jahan par the north pole या field is going to project. Kindly आप अपना left hand rule लगाकर check it out, ठीक है. Question number 33. An electromagnet is used to remove a splinter from an eye. Which material is the splinter made up of? This electromagnet is being used, it is made up of some magnetic material. So aluminium and glass and wood won't work. So C, iron is the only option. Question number 34. In a child's toy, metal fish are lifted out of the toy pond using a metal rod. The fish are magnetically attracted to the end of the rod. There is no magnetic force between the fish themselves. Okay. What are the possible materials from which the fish and the rod are made? Well, they've told you that there is no magnetic force between the fish themselves. So it would be made up of some magnetic material. Okay. And the metal rod is going to be made up of magnet. ठीक है. The fish is soft iron. ठीक है, वो permanent magnets नहीं है. And rod would be made up of steel, which is a permanent magnet. So D is going to be our correct option. ठीक हो गया? Question number 35. In which way are a bar magnet and an electromagnet similar? A bar magnet and an electromagnet are always magnetized when stored. No, that's not true. A bar magnet and an electromagnet can both be used to separate magnetic and non-magnetic materials. Yes, this is true. A bar magnet can be made up of steel, and the electromagnet uses a steel core. This is correct, but this is not similar now. The magnetic field strength of a bar magnet and an electromagnet can both be varied. The magnetic field strength of a bar magnet cannot be varied. Yes, that of an electromagnet can be varied. So 35 का answer would be B. ठीक है? Question number 36. Which statement about a permanent bar magnet is correct? It is made from soft magnetic material. No, it is made up of hard magnetic material, which is steel. It repels a non-magnetic material. Obviously, non-magnetic material repel तो नहीं करेगा पर attract भी नहीं करेगा. So, attraction repulsion की बात नहीं आएगी. Its field lines cross each other where the magnetic field is strong. No, the field lines never cross each other even if the magnetic field lines are strong. Its north pole repels the north pole of another magnet. Yes, this is correct. Question number 37. Which metal could be used for permanent magnet and which metal can be used for the core of an electromagnet? We know that the permanent magnet is made from a strong magnetic and hard magnetic material, which is steel, and the core of an electromagnet is made from soft iron. ठीक हो गया? Magnetic material is going to be steel and this is going to be iron, so D is the correct option. Question number 38. An electromagnet with a soft iron core is connected to a battery and an open switch. The soft iron core is just above some small soft iron nails. The switch is now left closed for a few seconds and then opened. Why do the soft iron, what do the soft iron nails do as the switch is closed? And what do they do when the switch is open? They are made up of soft iron. Okay? So they are not permanent magnets. So when the switch is on, they are going to get attracted to this electromagnet, and when the switch is off, so they are going to fall down. So as the switch is closed, so the nail jumps up, and when the switch is open, though this fall down. So A is the correct option. ठीक हो गया? अच्छा. Oh, sorry. Switch is closed. Question number 39. Okay, which metal is suitable to use to make a permanent magnet? Steel is the material that is suitable to make a permanent magnet. ठीक है? Question number 40. A permanent magnet is made from metal and electromagnet use metal core. Which metal is suitable for each of the purpose? For permanent magnet, steel is going to be used, and for core, iron is going to be used. Okay, moving forward to question number 41. A magnet is placed on a balance. The balance reading changes when an iron bar or another magnet is held close to the first magnet. The arrangements are shown in the diagram. Okay, this was 100 grams. And when an iron bar was brought near to it, so the reading iron bar is moved near it, so this is going to attract. So the reading over here is going to be uh, less than 100. And when two magnets are being closed together, so then it is going to be less than 100 as well. क्योंकि ये attract करेगा ना इसको, और here also the attraction is taking place, so that is why uh, both will be weight will be less than 100 grams. So A is our correct option. Question number 42. The diagram shows two bar magnets stored with metal keepers across the ends. The keepers held to keep the magnets magnetized. Okay. The material used for the keepers becomes strongly magnetized when placed in contact with the magnets, but does not remain magnetized when taken away from the magnets. What is the suitable metal used for the magnets, and what is the suitable metal used for keepers? Okay. When it is saying that they do not remain magnetized when it is taken away from the magnet, the keepers are going to be made up of magnetic material that's not permanent, rather it's temporary. The temporary is made from iron, soft iron, and the metal for the magnet is a permanent magnet. It's going to be made with steel. So metal for the keepers is iron, and then for the magnet is steel. So C is going to be our correct option. Okay, moving forward to question number 43. Which row correctly shows whether copper and steel are ferrous or non-ferrous? Okay, copper is non-ferrous, obviously, because it's not a magnetic material. So it's not ferrous. ठीक है, steel is ferrous, तो ये दोनों options भी कट गए. So copper is non-ferrous and steel is ferrous because this is magnetic and this is non-magnetic. So C is going to be the correct option. Okay, question number 44. Two iron nails hang from a bar magnet. Which diagram shows the magnetic poles induced in the nails? Okay, this is north, this is south. So this is going to be north, this is going to be south, this is north, this is south. So this is correct. South and south can't be there, so this won't be correct. North and south, south ke south north, then south again. There is going to be a repulsion over here. South, south, repulsion. So A is only the option that's correct. Moving on to question number 45. In which pairs are both metals ferrous? Yani both are magnetic materials. Aluminium and copper mein copper is not ferrous. Aluminium and steel mein aluminium is not ferrous. Copper and iron mein copper is not ferrous. Iron and steel mein both are ferrous. So 45 ka option is D. 46. A hard magnetic material can be used to make a permanent magnet. A soft magnetic material can be used to make a temporary magnet. Which row shows whether iron and steel are hard or soft magnetic materials? Iron is soft, steel is hard. So iron is soft and steel is hard. C is our correct option. Question number 47. An electromagnet is used to separate magnetic materials from a non-magnetic material. Why is steel not suitable for the core of the electromagnet? Steel is not suitable just for one reason, because it's a permanent magnet. Okay? So it forms a permanent magnet. So 47 ka answer is going to be A. Density, thermal capacity, good conductor of electricity, they don't matter. Question number 48. Which statement about magnetism is correct? Aluminium is a ferrous metal. No, aluminium is not a ferrous metal. A steel magnet can be demagnetized by heating it. Yes, it can be demagnetized, but let's look at the other option as well. The core of an electromagnet is usually made up of steel. No, it's made up of soft iron. The magnetic field around a bar magnet are evenly spaced. No, they are not evenly spaced. So B is our correct option. Okay, two soft iron rods are placed end to end inside a coil which is connected to a battery. The connections from the battery to the coil are now reversed. What happens to the soft iron rods in each case? Both connections are shown. Okay, battery connections are shown. So this is positive and this is negative. So attraction is going to be there. Rods are going to attract because one is going to have other charge and one is going to have other. ठीक है, तो rods are going to attract each other. Battery connections reverse होंगे तब भी rods are going to attract each other because over here अभी यहाँ पे positive और negative हो रहा है. If this is going to be negative and then negative and positive, so negative and positive still they are going to attract. ठीक है, so A is the correct option. Question number 50. Some electrical devices require a magnet which may be switched on and off many times in a second. Which type of magnet can be used? Obviously, it won't be a permanent magnet, it's going to be a temporary magnet. So it's going to be an electromagnet only. So A is our correct option. Question number 51. Two bars of soft iron placed near a bar magnet. Yes, this is soft iron, this is soft iron. Which row states and explains the behavior of poles P, Q of the soft iron bars? Okay. P and Q, basically if this is going here, तो यहाँ north होगा, यहाँ south होगा. ठीक है, because they are going to be attracted. And if there is north over south over here, तो north यहाँ होगा. और फिर अगर आपको इसको इंड्यूस करना है तो यहाँ साउथ आ जाएगा. ठीक है, तो they are going to attract and P and Q both are unlike poles. ठीक है, as I've just stated that. Okay. Question number 52. Which row shows whether iron and steel are ferrous or non-ferrous? Iron and steel both are ferrous because they are both magnetic materials. ठीक है, so A is the correct option. Question number 53. The north pole of a magnet repels one end of bar X. What happens to the other end of bar X near to the poles of the magnet? If the north pole of the magnet repels one end of the bar magnet, agar this is being repelled, so over here this is going to be north and over here it's going to be south. So once the other end of the bar X is placed near the poles of the magnet and if it's placed near this pole, so up it's going to attract. Other pole near north pole, it's going to attract. ठीक है, and the other pole near the south pole, so it's going to repel. ठीक है, B is the correct option because south over here and north over here, so they are going to attract, and if this end is placed over here, so south and south are going to come in contact, तो repulsion होगी. ठीक है. Okay, moving on to question number 54. A student wishes to make a permanent magnet. She has an iron rod and a steel rod. Which rod should she use to make a permanent magnet in this rod? Is this rod a hard magnetic material or a soft magnetic material? She has to use steel rod to make a permanent magnet, and obviously it's hard magnetic material. So C is going to be the correct option. Question number 55. The diagram shows a magnet being brought near to an unmagnetized iron bar. Okay, this causes the iron bar to become magnetized. Which pole, magnetic pole is induced at X, and how is the iron bar affected? Okay, if over here this is south, so here it's going to be north. ठीक है, the pole induced is going to be north and the effect on the bar is attraction. A is the correct option. ठीक हो गया. Question number 56. Which statement describes the property of magnet? It attracts ferrous materials. Yes, this is correct. It could have only one pole. No, that is not correct. It points in a random direction when suspended. No, it points towards north-south direction according to the north and south pole of the earth. It repels non-ferrous material. It doesn't repel Non-ferrous material, there is no repulsion or attraction either. Okay, so A is going to be the correct option. Question number 57. Four nails A, B, C, D are tested to find which makes the strongest permanent magnet. One of the nail is placed placed against a bar magnet, and the number of paper clips which the nail can support is recorded. The bar magnet is then removed and the number of paper clips remains attached to the nail is recorded. Each nail is tested in turn. Which nail becomes the strongest permanent magnet? The strongest permanent magnet which retains the maximum number of paper clips even when the bar magnet is removed. ठीक है ना? Because it is a permanent magnet. So bar magnet present में two paper clips hai and bar magnet removed so 0. So this is not going to be a strongest permanent magnet. This is 2 and this is 1. Okay. When the bar magnet was present, though, it was collecting 4, and when it was removed, it had 3. So this is going to be the strongest magnet. Okay. Even when the bar magnet was connected, though, it was collecting quite a few. And when it has been removed, though, it has quite a few as well. So this is going to be the strongest magnet. Okay. 58. The horseshoe magnet is brought near to an unmagnetized iron bar. Okay, which row in the table shows the magnetic poles induced in the iron bar and the direction of the forces between the bar and the magnet? Okay, if this is north, so this is going to be south, and this is going to be north, and साउथ एंड नॉर्थ सो सी ये दोनों तो नहीं सी और डी होंगे एंड इट इज गोइंग टू बी अट्रैक्टेड सो सी पे it's going to be both the options are going to be correct, so C is the correct option. ठीक हो गया? Moving on to question number 59. Which statement about a magnet is not correct? Whenever you see not correct na, to kindly underline it with your pencil. It can attract in another magnet. This is correct. It can attract an unmagnetized piece of iron. Yes, this is correct. It can repel another magnet. Yes. And it can repel an unmagnetized piece of iron. It can't repel, nor will it attract it cannot repel an unmagnetized piece of iron. It is going to attract it and not repel it. ठीक है? So it can't repel. So D is going to be our correct option, which is actually not correct. ठीक हो गया? Question number 60. The coil is connected to a battery and a soft iron bar is hung near to it. The current is then reversed by reversing the battery connections. How does the soft iron bar behave in the two cases? Okay, इसमें तो there is with the battery shown, so it's going to be attracted to the coil even when the battery is reversed, so it doesn't has any effect on this. Excuse me. So it is going to be attracted again because it's made up of soft iron. It's not a permanent magnet. It's a temporary magnet. So once this comes close to this, it is going to get magnetized. And if its connection is reversed as well and brought close to it, so it is going to be attracted to the coil. 60 ka answer is A. Okay, question number 61. A chain of steel nails and a chain of iron nails hang from a strong magnet. The chains are then carefully removed from the magnet. What happens to the chains? Both chains fall apart? No. Both chains stay together? No. Only the chain with the iron nail falls apart. Yes, this is correct because iron was temporary magnet and steel was permanent magnet. So this is going to stay together and this is going to fall down. So 61 ka answer is C. Moving on to question number 62. A permanent magnet is brought near a piece of copper. The copper is not attracted to the magnet. Why is there no attraction? Because copper is a non-ferrous material. Copper is ferrous? No, copper is not ferrous. Copper is ferrous but is not attracted to any type of magnet. This can't be true. Copper is not ferrous and only attracted by electromagnet. This is not true. Copper is not ferrous and is not attracted by any type of magnet. This is the correct option. Okay, question number 63. A piece of iron and steel are picked up by an electromagnet is shown. The current to the electromagnet is switched off. What happens? Both iron and steel remain magnetized? No. Neither the iron nor the steel remain magnetized? No. Only the iron remain magnetized? No. Iron is used over here because it doesn't remain magnetized. It's not a permanent magnet. Only the steel remains magnetized because it's a permanent magnet. So question number 63 ka answer is D. Question number 64. Four are placed in the magnetic field of two identical bar magnets as shown in the diagram. Which compass is shown pointing in the wrong direction? Okay. If we look at option A, the north is here. So this is placed here. So this is pointing correctly. When it is placed near the north pole end, if north pole is over here, so it is going to point towards the opposite direction. So B is correct as well. If we look at option C, north is over here, so north of the earth is going to be in the opposite direction, so C is correct as well. And if south is over here, it should point towards the north like this, because north would is the one that is giving the wrong directions. Okay, we've done one such question before as well. Question number 65. The north pole of a bar magnet is placed next to end P of the iron bar PQ as shown. As a result, magnetic poles are induced on the iron bar. What are the magnetic poles induced at P and Q? If this obviously is going to be attracted towards north pole, so over here south is going to be induced and over here north is going to be induced. So magnetic pole at P would be south and at Q would be N. So C is our correct option. So this brings us to the end of our topic 4.1, which was simple phenomena of magnetism. So kindly like and subscribe the channel. If you found anything helpful in the videos, kindly remember me in your prayers and take care of yourselves until our next video. Thank you and Allah Hafiz.